Well, hello, everybody, and welcome to SkyTour Livestream for today, April 17th, 2023. It is I, Marc D'Antonio, here as always with our good friend Daryl Mason. Hello, Daryl. How you doing?
Mark, I'm good. You? Hello, everybody.
Doing fine, thank you. Doing fine. This is a good night. We're going to be spending some time looking at galaxies and maybe some star clusters too. I think it's fun. I want to say hello to the people that got here first. Judy M is here. Hi, Judy. Terry Haig is next in line. Michael Hedrick is with us. And it's just the beginning. More people will be joining us shortly, I'm sure. Izabela is here. Hello, Izabela.
Hello, Izabela.
Izabela doesn't get any sleep, does she?
Probably not enough.
No, she doesn't. She spends too much time hanging out with the SkyTour live streamers. But you know what's good? It's a good thing because we're learning about the universe, and it's nice to be able to share what I know about the universe with people too. Because I think that most people love finding out what's over their heads. You know, like what we should do someday. We should have a star contest where we show an image like this, okay, and we let people try to figure out where it is, and if they win, then they get like a SkyTour live stream thingamabob, maybe a refrigerator magnet or something like that, you know. But we have to be careful. There might be people out there that just do a photo and do a plate solve, right?
That could well be.
Yeah.
I mean, like here, I assume this is Sirius.
It is not. It's actually Pollux.
Oh, okay.
Sirius is way brighter than that. But again, if you look here, it's a 1 second exposure, as you can see over here. And the 1 second exposure is very important. Let me just quickly swap something out here. There we go. Okay. 1 second. And then this one. There we go. Okay.
So, Pollux, huh?
Yeah, that's right. Pollux, a K3 giant.
Yeah. Pollux is one of the twins in Gemini.
Yep.
I would wonder if they would even call them twins by today's standards, because they were only half brothers. They had different fathers. I would think that would kind of negate them being twins, or unless they called them Irish twins or something. They went off on a cattle raiding party and a cattle raid, and Castor got killed and Pollux lived.
Wow, interesting. Izabela is going to be in and out of chat tonight, but nice to see you, Izabela. Thank you for dropping by. Hang out with us all you like. You're more than welcome here. Let me come back in here. Oh. Arrow's pointing, of course, at Pollux. And let's drag our control over where it needs to be. There we go. Alright, there we are. Okay. So it's just getting fully dark out there. Our program, our planetarium program, shows us a little bit of what's going on out there. There's the Gemini twins right there, in case you were wondering. Okay, we can actually show the artwork. There they are. Ta-da! Castor and Pollux. Okay. And hello, Poison Arrow Frog. What's going on, man? And Alice Pooper, good to see you.
And if you draw a line from Pollux to Betelgeuse, you'll see one single fairly bright star almost in the middle between the two. That star is called Alhena. It's Pollux's foot.
That's right.
If you ever see the winter circle or the winter hexagon, all the bright stars make the hexagon shape, and then there's a star close to the middle, and that's Alhena also.
So we draw a line from Pollux down to Betelgeuse, like this. And
a little more than halfway.
So right about there.
Yeah, that star is called Alhena.
That's it.
Pollux's left foot.
See that, guys? I like the fact that I added the ability to draw directly onto our view, so you can actually see things. I can outline stuff and show you stuff. I think that's it's called a telestrator capability, and it's something that I added because it's really important that when you say, now see that star over there, which star where? They're everywhere, right? So this helps figure that out. Yeah. It is a great night to be here. Thank you, Poison. And hello, Proud. Nice to see you. Okay. So we're gonna check a few things out. We're gonna see what the sky looks like. I mean, if I back out a little bit here, you can see that it looks almost dark. It's not quite dark. We got a little ways more to go for astronomical twilight. If you notice where the Orion Nebula is now, down here in Orion, I mean, if we superimpose in fact, get rid of our equatorial lines here for a second, and just look at the altitude, the Orion Nebula is only 25 degrees above the horizon now. And that's when it's dark enough to look at the sky. So that's they're pretty much, the stars of winter are heading on out.
Oh, yeah.
But we will have a little longer view to look at some of the objects, a little longer time, rather, to look at the objects up here. You know. Now,
a couple of things of note.
Yeah.
Recently that you can see if you go out and look. First, the winter circle or the winter hexagon is disappearing as Orion sets now, and Sirius sets about the same time in Canis Major. And then what is left are the easternmost stars in the winter hexagon or the winter circle.
Yeah. And
they call that the Arch of Spring. That's Capella in Auriga, Castor and Pollux in Gemini, and Procyon in Canis Minor.
Well, let's actually look at those then. Okay, so over here is Capella, and we can actually draw that line to show folks. So from Capella where?
Castor.
Okay, so Capella up to Castor.
And then on to Pollux.
Okay, right there. Then on to Pollux.
Yep. And then to the lower left down to Procyon.
Okay.
And that'll be all that's left sticking above the horizon once Orion and Sirius sets.
Wow, okay.
And that's called the Arch of Spring.
The Arch of Spring, right there. Yep. Interesting. Okay.
Anyway.
Oh, thank you, Daryl.
Yeah, I'm boring.
No, actually, I think a lot of people rather enjoy that. But what we'll look at now is one that we can see, which is this guy right here. This is a wonderful little cluster of stars. You got to wonder how they appear like this, you know. Let's just move the telescope a little bit, and we'll move to the east a little. Just center it up. And then we'll zoom in on it, because why not? And you'll notice something interesting about this little cluster of stars. Do you see what it looks like? Let me help you out. Doesn't this look like a 3?
Oh. Duh.
And doesn't this look like a 7?
Yep.
This is called the 37 cluster. Now, that doesn't mean that these stars are actually spelling out the 37. That's just what it looks like. Hello, Fantasy. That's right. You'll be kissing its butt goodbye in just a few weeks. And as you can tell when you look in the observatory feed right here, you can actually see insects flying by the infrared system out there. Hey, Corey Williams. Thanks for coming out. Let's see. Corey says, I wonder what would happen if we were orbiting Jupiter. I once saw the orange and white stripes of Jupiter and was so excited. Obviously, I'm an amateur. It doesn't matter, Corey.
I hate to break it to you, you would die.
Well,
the radiation is so intense around Jupiter that it would mess you up and ultimately kill you.
It's about 20 times the magnitude of the Earth's radiation belts, because the magnetic field is 20 times the strength of Earth's, and it's a lot larger. So yeah, but that's okay, Corey. That's a wonderful thing to muse about. I think that's pretty cool. A lot of science fiction authors love to tackle that and just imagine what would happen if we could, right? So that's what happens, though. There's a lot of dangerous radiation around Jupiter.
There's a series of posters out there, I forget offhand what they're called, showing man exploring around the moons of Jupiter, ski Europa and stuff like that, like travel posters.
Ski Europa, yeah.
The radiation part is what they don't tell you.
Yeah, skiing Europa would be a fatal endeavor. Okay, we're starting a quick stack of the 37 cluster because, again, why not? They say, wait, that looks gross. It does, because it's the first exposure. It's not color corrected. Now it is. And then we will actually set the levels and set them properly and remove this additional bit over there. And now you can see the 37. A lot of orange light because of sunset still lighting the sky with some orange light that may not even be visible to your eye, but it's definitely visible to the camera. If you look where the telescope's pointing, it's pointing that way. That way is west, that way is east, and coming out at you is south, and going into the page is north. So the observatory is set up on the cardinal points almost. And Michael Hedrick says he's the radiation guru, Daryl.
I see that. Are you radioactive, Michael?
Radioactive. That's better. Isn't that beautiful? The 37 cluster looks really stunning. I'm actually going to save this one. We're going to call it the 37 cluster. Okay, we've taken 7 shots of it so far. And I'm going to just play with the levels a little bit, just to give us something a little bit more manageable. That's really pretty. Gosh, that's pretty. There we go. And I'll save it just like that. And save exactly as seen. All right. Now meanwhile, we'll keep going on this. And let's go check out something else that we might want to look at. Hey there, Papa Tom. Nice to see you. I think I'd like to, I think I know what I want to go see. It's not quite dark enough for it, though. I want to go to LDN 1622. Because we didn't look at it last time.
The Boogeyman.
Yeah. We'll try the antennae as well. They're in Hydra or Crater.
Corvus?
Corvus, that's what I meant. They're in that old crow.
Galaxies are what you want to look at. It might be good to start up in the north and then work our way south.
Yeah, because we can go to Bode's.
Yeah, the north will be easier to see early on.
It will, yeah. That's right.
And as we work our way south, then
It gets darker.
stuff in the southeast will have risen higher.
Yeah.
Easier to get at, like Virgo and Corvus and all that.
Yeah. Good deal. Let's take and save one more version here. We'll save this one. This is nice. I just want to view Sigma stacking. Okay. (16-bit) and save exactly as seen. All right. Okay. It's not quite dark enough, but we can still have some fun out there. Let's go and take our night vision mode again. Bring that up. Okay, there's our night vision mode. Hello, Michael Galea. How are you? Good to see you. And from here, we're going to go check out something else. Let me get this out of here. That's something you're seeing there now. Okay, let's do this. Okay. I'm just looking for another object here that I want to find. No, I just went and I looked online here and I'm like, oh, look, it says Galaxy Season, Arizona Sky. Somebody named a stream after mine. Oh, no, that is mine. Oops. Yeah, my head's a little mushy today. Okay, let's go and do this. I'll be right with you here, guys. We'll be doing the next thing here in just a minute. So how are you guys doing anyway? I hope that you are having a good time tonight, and I hope that you are all here having a nice warm night. I know some parts of the country are still pretty cold. Okay, I know where I'm going. Like where you are, is it still cold, Daryl?
It's still cold where I am?
Yeah.
Well, it snowed a couple of days ago, and then it warmed up, and today got close to 70. Tomorrow's supposed to be low to mid 70s, and then it is supposed to cool down again.
Oh, okay.
Springtime in the Rockies.
Yeah.
There's an old saying here that in Colorado, winter's in spring, summer's in fall, fall's in winter, and there's no spring at all.
That's right. You said that before. That's funny. Sad, but true, isn't it?
You get used to it.
I don't think so.
We had a late snow a 3 years ago, almost in June, and it snowed real heavy, wet snow.
Wow.
Almost killed one of my trees. Like to split it in two.
Wow.
Usually it's February is nicer than March, and March is nicer than April.
Yeah.
It eventually starts getting nice in May. That's when you start seeing flowers here.
Okay.
Except for crocus and some of the really early ones. Daffodils, perhaps. We do go straight into summer, though.
Gotcha.
All of a sudden, it goes from too cold to too hot, just like that.
Mm-hmm.
M3.
Sure. I think we can do it.
Hey, you're in coma.
I'm not in a coma.
You're in coma Berenices.
That's right. I'm in a pile of hair. See, look. You watch the telescope moving across there. It's going to keep going over toward that side, toward the east, because this is an eastern object that's coming up. And we should be just on the border of being able to see this. But it looks like we're going to have interference. This glow you see that's red shows us that it's not quite yet above the building wall. That's okay. If we go back down, drop this down in size. There is the globular cluster. Go ahead.
Too early for coma then?
Just a little bit.
Yeah, you're between coma and Boötes actually.
Yeah.
Well, still fairly early in springtime, I suppose.
Yeah. Hey there, Asher. How are you? Hey, C&D boy. Thanks for coming to the stream tonight. See, even if we have the a little bit of the wall blocking us right now, actually, this may be close. This might be clear. We're gonna try this. This might be clear. I see a little red. I'm not sure if that's the sunset light that's interfering, but you see how the telescope's aiming right along the edge of the building there, and it looks like it may be just clear. Let's just give it a little shot here. If we move it west a little bit, even though it's off center, it just might bring it up just enough. West, remember, is that way. Okay, so here's what we're going to do. Let's try this. Okay, so we'll give this now a 10-second shot. Man, we've got Starlink satellites all over the place tonight. No excuse for a service. Okay, so here's 10 seconds, and the progress bar you can't see, but I'm gonna make sure you can in just a sec. But I'll get our live stack up first. We're gonna clear that. All right. Okay, and now let's do this. We're gonna get rid of this. Color correct. And do a mid-level process. Yeah, we got the edge of the building there still. But you can see this beautiful globular cluster. This is called Messier 3. That's actually kind of a pretty composition. Yeah, nice. Okay, so first things first, let me bring us back up. Bring this back up just enough so you can see that. I want you to see that bottom row. There you go. Okay, this bottom row, that's the progress bar over here on the right here. That's what I want you to see.
My mistake. This is Canis Venetici. Messier 3.
Okay. Asher, yeah, Seattle, tough location. I've been in Seattle, and it's cloudy at night much of the year. It doesn't seem to get clear much out there. So that's like having a telescope in Ireland. You know, there's really no reason to put a telescope there because there's never any clear skies to use them. But let's zoom in on this, even though it's compromised.
Give you an idea of how impressive the cluster actually is. It is about 34,000 light years away.
Mm-hmm.
So it's quite distant.
Now let's sharpen it up a little bit. Here, I just added a sharpening to it. That's pretty. And this is a globular cluster. It's called a halo object. It orbits the galaxy. It doesn't have an orbit in the galaxy. It's outside the galaxy. You know, kind of orbiting around the galaxy, sometimes punching through the spiral arms and then down below and then coming up through the spiral arms again on the other side. They're really interesting objects.
It's about 500,000 stars.
Yeah, 500,000 stars is an awful lot of stars. Without a doubt. Yeah, without a doubt.
Papa Tom, I saw a couple of images purportedly from the web. I went looking at the website, and they didn't have a thing about Pluto on there. I gather the Webb telescope has been, or Hubble has been looking at the planets again lately.
That's right. I think I'm trying to remember which one I saw. They imaged another one of the Jovian satellites or Jovian moons around Jupiter. I'm not sure. Maybe it was Titan actually around Saturn. Or James Webb looked at Titan.
It's hard to keep up with them anymore.
It is.
Robert?
Robert Fracchia, how are you? Good to see you. Yeah, this is a globular cluster. And I'm just trying to figure out a way to capture this in a little better. I mean, it's just on the edge of the building. There's a tiny red LED on the back of the camera. The camera's normally at the back of the telescope. You wouldn't care about it, but because it's in the front of the telescope, because we're using it at an f8 telescope at f2, that's a much faster photographically. The telescope is actually doing a marvelous job trying to photograph a very bright sky and still let us see the astronomical objects at much faster photographically, which means it's shorter exposures. So something like this might take, say, 1.5 minutes to capture like this, maybe 2 minutes with the f8 telescope. But with this, it's 10 seconds. So that's, quite cool. All right, let me do something here now. Oh. Okay. So this guy right there. This is Measure 3, a globular cluster. All right, and once again, we call it by the simple name M3. It's a little out of guiding here because the guider is actually also behind the wall of the observatory, and the guider cannot see a star to guide with, so it's kind of stuck right now. Alright, so let's go look for another object to go to. It'll have to be, we say it has to be above 40 or 42 degrees or so at that corner. This is very close to, you're saying that's Canis Venatici, huh? I guess it is. Let's zoom in there. Yeah. Well, how about that? It is. Alright, well, there's something else in Canis Venatici, which is something we can probably see. So let's go there. We can come back to this later. So let's do that. I won't save it yet because that's not a very good shot of it, and it's got the red hue because it's hitting the edge of the building. But let's go back to our night vision mode here and navigate to this next one. And this guy here, zap. go away. There we go. All right. Night vision. All right, and now we can go to a beautiful galaxy. A galaxy familiar to us. Telescope is going to barely move. It's just heading toward a little bit, slightly more north, and best for us is that it will have us perfectly in place for a beautiful view of the galaxy. It's going to be outside the building confines. There it is, and we'll bring that down into the view.
M51.
You got it. This is the Whirlpool Galaxy. This galaxy is fascinating because it's a galaxy in collision. We're watching two galaxies colliding with each other. This one here is actually colliding with this one here. Now here's the interesting thing. There's research indicating that this small galaxy, by colliding with this galaxy here, caused its spiral arms. Interesting. And that's something that's a fascinating topic. Hello, Sam S. Alright. Right, now what we'll do is we'll do a... let's do a 25-second shot of this galaxy. Have a satellite going through it as well. Okay, our special little progress bar is going over there. Okay. And when I talk about the galaxy, what I'm talking about is this galaxy right here. Okay, that's a satellite galaxy, and this is the main galaxy, right? Well, by this one interacting with this one, watch this spiral arm. It's pulled this arm out. Okay, so let's go back now and let's check it out. And to see it, we're going to go here and clear. Get rid of our extra hyperring there, and we're 10 seconds from seeing this galaxy in a better light. No pun intended. Well, yeah, pun intended. So here we go. Ready? Bing. Now there is the Whirlpool Galaxy. We can start zooming in on this almost immediately because it's going to start looking better very quickly. I'll come back out a little bit. Now, what's interesting about the galaxy is this is that second galaxy that's passed by it at least once, but there's a large spray of stars out here that may become evident shortly. And that large spray of stars out there could have come from this galaxy or this galaxy. I'm not sure which. So we'll see what happens as we continue here. Let's color correct. There you go. Now with color correction, it looks good. You see a red hue there. This is because of the sunset still. But we can just tone this down a little. I'll come up a little bit. Yeah, it's really pretty. This guy is really interesting. Remember I talked about the spiral arm here? See how it's actually poked out there? You can see it right here. Okay, this spiral arm is... Oh, wow, hey, look, I almost got hit by a Starlink. Okay, this is the spiral arm of this galaxy here that's been pulled toward this one. Okay, that's how that works. And then the thing is, though, this galaxy is further into the page than this galaxy. This galaxy is like out here, and then that galaxy is out down here, so it's further in. And so when you look at this from the side... All right, all of our studies seem to indicate that that galaxy looks like this from the side. It's actually warped down. That spiral arm that's pointed like that is actually warped downward a little bit. That's pretty interesting. You know?
Little satellite trails.
It looks like this Tholian web here from Star Trek.
Getting there.
Yeah. Well, these are 5 stacked frames, and this will disappear. I'll clear it. Why not? We can deal with it. Such is the way it is. Okay. And now, once again, the Whirlpool Galaxy. So you see how fuzzy it looks right now? It looks fuzzy like this because we just have one exposure, right? So we're taking a second one and we're aligning it with the first and stacking it on top and making an image sandwich. What that does is it takes all the data we want to see and brings it to the top. And the data we don't want to see, like the noise in between here, goes away. Watch the change here and right now. Ready? See that? Look how much clearer it just got. That's stacked 2 images now. When we stack 3, 4, 5, 6, 7, it gets even better. And that's pretty cool.
Have you run a focus yet tonight?
I did.
Okay.
Yep. And temperature compensation is on. I just turned it on. Oh, but we need to do it again. Sorry, guys. I just realized we have to do it again. I did it earlier, and we're going to do it again.
Do focus?
There's a little bit out of focus, yeah.
Okay.
See that star right there?
Yeah.
Yeah, not in focus, not in focus. So what we're going to do is we're going to pull it out of focus and let the telescope find its focus. And you'll see what happens when we go out of focus with the stars. In general, oh wait, no you won't, not here. Now you will, once I do our 1 second night vision. These are always going to be way out of focus. Right, so now I will come in. Right, and as the stars get smaller, you'll end up seeing how their color becomes a little bit more visible. But unfortunately, in this green, it's not that good, and so that's not going to help us too much. But if you photograph stars slightly out of focus, it gives you their colors really nicely. I'm glad you like that, Robert. I think that, I'm kind of limited here. I'm just a head in a box, right? So I figure if I can move around a little bit, then that'll show you what's going on. At least you can see exactly what I'm pointing to. I could point there with this and all that, but it's much better if you can see what I'm pointing to with the flexibility of the hand. Okay, so here's what we're going to do. We're going to now bring our focus down here, our focus box. All right. Trying to get the focus box going. We are going, yeah. There we are. Okay. And let's... We're a little behind here, I see. Let's see if that's going to stick around. And then we're going to go in on this. All right. So now we're building a focus curve, and the stars are all going to get smaller. As long as I went the right way, I got to make sure I did. I think I went the wrong way. Okay. We're going to stop this and do it again. First things first, let me try... We got a delay going here, so that's the problem. Okay. Each of those round donuts is actually a star. There we go. Okay. I'm just waiting for our satellite to catch up here. Sometimes there's gaps. We have a few minutes every day where we don't have Starlink. But it's okay.
Speaking of, I got up early this morning to see if the Starship was going to take off.
And it did not.
And it didn't. I think they're saying Thursday the 20th now.
Okay.
About the same time.
Mm-hmm.
It's like 8:15 Eastern time, I think, or something like that.
Okay. Our star images are getting smaller, and you can see we have 60 stars now. 67, 65 stars. And that's actually covering the whole frame. We're kind of zoomed in. So, being that we're zoomed in, we don't actually have to, this is not the only stars we're seeing. They're actually throughout the whole image.
Yeah, Musk said, teething pains. First time they're actually trying to launch the complete assembly.
Mm-hmm.
He said as long as they didn't blow up his launch pad, he was happy.
You need that sense of humor if you're going to do this.
Oh, yeah.
Mm-hmm. Okay. So we're running focus out, and then we're going to run it back in. All right, so now we are focused. So we can get rid of this.
When it goes, however it goes, I bet it's going to be spectacular.
I bet it will. I'm going to bring us and reconnect us. See if it makes a difference. Let's see how that works. Sometimes reconnecting changes our connection speed, and I think it's worked. All right, so here's what we're going to do. We're going to do a 25-second shot of this again, and it will now be focused. All right, and you can see our progress bar down there is moving across. Bring up our live stack now. Get our image sandwich running. And we'll clear this one. That's the old one. And we'll clear this extra. And now we have 5 seconds. 3, 2, 1, 0. And Whirlpool Galaxy. Look at that. Wow. Looks really pretty. And it's all focused finally. Nice.
Turn T-comp back on now.
I will, yeah. Just making sure what we're looking at is good. This is Measure 51, the Whirlpool Galaxy. Alright. Temperature compensation is on. Focus has remained unchanged. The temperature is 21.7 Celsius right now at the telescope. Out in the building right there. It's pretty warm. RJP, what's going on? I didn't see you up there. Nice to see you. David Galich, how are you? Gladys, hi man, how are you? Curtis, how you doing? Good to see you as well. Very nice to see you. Lewis, nice to see you. Yeah, Lewis says that's hot. It is pretty warm out there. Okay, remember that? Okay, I mentioned to you earlier, I talked about that right over here in the galaxy at the end of the tail here, there is another additional area here of gas and stars that are trailing. And that tells me, as you'll see in a second, that tells me that this small satellite galaxy has already gone through this galaxy at least once, and might actually have pulled other stars out with it, or these are stars from it that are being distributed and pulled by this galaxy back. Let me illustrate that. Let me show them to you. If we pull this in just a little bit, increase our shot here, you can see there's gas and dust out here now. There's these other stars that are being pulled out. There's a vast quantity of them out here. Now, how did that happen? That's a really good question. I'm going to try and let's see if I can compensate and give us a little bit of better view. All right. So you can see that there's a vast cloud out here of these additional stars. So the Whirlpool Galaxy presents a conundrum. It's like, how did it happen like this? How did it form like this? And what's actually happening? Which galaxy is going through which galaxy? And is it the Whirlpool, this one, that is going through the satellite, or did the satellite get destroyed by the Whirlpool? Initially, it looks like the Whirlpool Galaxy existed beforehand, but that the spiral arms were actually caused by this galaxy coming into close proximity. There's a process that galactic theorists, astrophysicists talk about, that talks about ways in which spiral arms form. One is the density wave theory, and the other is the perturbation by another galaxy that might cause spiral arms to form like ripples in water, kind of a thing. And ripples in water is not a good analogy other than to say a rock dropping in water will cause something. Well, a galaxy dropping in another galaxy will cause something. And it causes its own type of ripples, which happen to be the spiral arms, because everything is rotating. It's pretty cool. Hey, Curtis, thank you. Curtis shared the live stream on Reddit, Facebook, and Twitter. Yeah, I gotta try and share to Reddit. I didn't know that I could do that. I thought Reddit was for photographs. I didn't know if they do that. You probably shared the link. Is that what you did? Yes, David Galish, it's a cosmic collision. That's correct. Of the highest order. Who knows the chaos that's ensued in here? But you can see this line of other stars out here. Look at that. Look at that. Let me draw the contrast in just a bit so you can see that a little clearer.
We're on Reddit right now?
I don't know if we're on Reddit per se. I have to find out from Curtis what he did. Hey there, Keith Evans. How are you? Yes, Keith, the telescope is about 70 miles west of Phoenix, out in the desert. You got to drive 14 miles of dirt roads to get to it. And we're not at ground level. We're up around, I'd say, about 2,000 feet in elevation. So not that high, but high enough where, there is a slight difference in the weather out there. Oh, very cool, Curtis. He has his own EAA subreddit that he created. Well, yeah, you can put a link to that, Curtis, if you want to. Yeah, it's a beautiful galaxy. You're absolutely right, C&D boy. Let's zoom in more now. I think we can. I'm going to draw the contrast in a little bit more so we can get a little bit better, darker sky in the background. And now, look at all the chaos in here. Look at all this chaos. Wow.
You can see some of the fainter stuff to the upper right.
Yeah, that's what I'm...
the satellite. Yeah.
Yeah. That's pretty obviously there now, which I really think is cool. I absolutely am a big fan of desert telescopes. Thank you, Curtis, for putting that up. Curtis put up his link, guys, if you want to check it out. See, what we're doing is remote access astronomy. Okay, this is this telescope right here is 2,500 miles from me, out in the Arizona desert. I'm in Connecticut, the opposite side of the country, running it from here, and it seems like an amazing feat to me to be able to do that. It just seems so strange because it's hard to believe it's actually happening, because I'm running all this equipment out there from so far away. Now, here's the thing that's interesting. I ended up spending about a year or two working on getting it remote, and that telescope that you see there was out here, and it was our Eastern telescope for quite a while, and that was while I was working out all the bugs, and then I moved it out there where it became the Western telescope, and then we installed it out there, and the first time we tried to install it, it went haywire, and it was like, oh no. The first day we tried it, it failed miserably, and that was actually a mechanical fault inside the telescope. But I took it down to Starizona in Tucson, Arizona, and Starizona, David down at Starizona, was able to repair this telescope like nothing. So because of their capabilities, I became very confident that we could surmount any problems that we would encounter out in the desert. And so far we have. They've been very helpful. So Starizona in Tucson, Arizona is probably one of the best places to get your equipment. And they stand by it, trust me. So Dean Koenig at Starizona, if I wore a hat, it'd be off to you, because without you, none of this would happen right now. You've actually done some really nice stuff for us. And the view you're getting is courtesy of a Starizona special. And they make something called the Hyperstar. Now, I think that was the equivalent of the Fast Star for Celestron, right?
Yes.
Yeah. And the Fast Star is a way to use a telescope that's normally slower photographically and turn it into a faster telescope. Our telescope, the type of telescope we had, didn't ever have a Hyperstar. It couldn't run faster. There was nothing made for it. But Dean Koenig at Starizona said, hey, maybe we can make one. So they did. And it works. And so this telescope we have right here is the only one in the world right now that actually has a Hyperstar on it of this type. This is a Meade LX600 10-inch telescope. It's normally an f8. That's a photographic number that gives you an idea how fast it is photographically. And we turned it into an f2. So it's about 25 times faster than an f8. And so this is a 25-second shot of something that would take many minutes to capture, especially this faint stuff out here. So I can't complain. Now the next telescope we're getting is actually going to be allowing us to say, let me show you the full field first, then I'll tell you what we're getting. Okay, this is the full field right here. 4 full moons across and 3 full moons tall. All right. So that's how big the Whirlpool is, but in this telescope. But when we get the next telescope, we're gonna have a view of like this natively. That's how big the galaxy is gonna appear in that telescope. And what we're gonna do is we're gonna run this telescope and the new telescope at the same time, and you'll have side-by-side images of a close-up of this galaxy, for instance, and the wide view of the galaxy. This is especially interesting when we start looking at nebulas, and like when we're looking at, say, the Horsehead Nebula. We'll close in on the Horsehead, see just the Horsehead, and then the whole region around the Horsehead we'll be able to see, and that's really cool. Yeah, Gladys says Starizona, what a great name. Yeah, they got the best name of any type of place for astronomy. And it's Starizona, has Arizona in the title. I think that's pretty cool. Yep. Alright, so we've done 28 frames, and I think we're going to stop it at this right here, because that's good. We're named Whirlpool Galaxy. It says Whirlpools. That's not right. It's supposed to be Whirlpool.
Marc, Poison Arrow Frog asks, what is the current focal length?
The current focal length of the telescope is 525 millimeters. Yeah. Yeah. Cosmic Ray says Starizona was showing their stuff at the NEAF. That was the astronomical conference that just happened, I think. And I'm going to try to actually get in there as a speaker for next year. And I think it might be pretty cool. I never even thought about it. And it's like, geez, well, why not?
New York City, isn't it?
I don't know where it was held.
I want to say New York City.
Hey, JSU. Well, Cosmic Ray will tell us he was probably there. Okay. Let's save it now. Alright, and save it exactly as seen. Awesome. Alright.
Pretty galaxy.
It is. Let's zoom in one more time and play with some of the... There we go. That's about right. So there's our faint material. Alright, we pull that in really far, really overblow it, and you can see all that stuff out there.
Ray says Suffolk, New York, north of New York City.
Okay.
Rockland Community College.
That's cool.
NEAF's one that's been around a long time, I think.
Yeah, it has.
It's like an annual spring expo for a lot of vendors show up, show their wares. I gather ZWO had a lot of stuff on display there.
I'm guessing they probably did.
New cameras, they're getting into their own telescopes now, and either that or they're just rebadged by somebody else, but I think they're calling them ZWO. And they have two mounts now. They had that one EM5, I think they called it, that harmonic drive mount, and they have a lighter duty one now called the EM3, also a harmonic drive.
Yeah, I want a. I was thinking of. I'll tell you what the harmonic drive is in a minute, guys. I want one of those harmonic drives. I was thinking maybe that would work for our telescope combo, but the weight is too close to the limit. Because we're going to carry the tube assembly, the guider system, and I just don't know if it'll handle it long term. Especially with the weather changes and stuff there. But because the weight, I mean, the tube assembly itself, I think was like 35, 45 pounds. And then we have the guider on top of it. So it's hefty.
You're probably stuck with either another fork mount or a conventional German equatorial or something.
Well, the GEMS, German equatorial mounts, are beautiful, and you just need room for that counterweight. And the nice thing about the harmonic drive is that it doesn't need a counterweight.
That's a qualified statement.
Yes, I mean...
To a degree, if you put a heavy load on it, you need the counterweight.
Right. But the counterweight shaft is a lot shorter because you already have the harmonic drive that's managing a certain amount of weight off its main axis, so the counterweight doesn't have to be that much. The shorter the lever arm, the less the motors have to work anyway. As long as it's all balanced.
Yep.
Okay, so now we saw M3. It wasn't quite above the building. We'll wait for it. Let's go see how high it is now. It's close to 45, so I'm sure it's good now. But we'll wait on that. But I want to look at this guy. Yeah, this is the Pinwheel.
In 101.
Yeah, this one's beautiful.
Nice, big, pretty galaxy.
Yeah, and this is just about the height of the Measure 3, the Globular Cluster. So we're going to find out how well this looks. There it is. That's nice. Okay. So let's go look. Let's bring it into perspective. Curtis Horn, this scope is a Meade LX600 modified from F8 to F2. Oh, sorry, Daryl. I didn't realize
No worries.
you're answering them. It's always better in print anyway. All right. So now... Alright, so this guy... Bow. Hello.
Mark, can you excuse me a moment, please?
Sure.
Right there.
Alright, let's do this now. Let's do a... our guider is going over here. If you look up here, okay, these numbers tell us our guiding values, okay, in right ascension and declination. Small percentages of an arc second that it's guiding. And then, so now we're guiding with precision that will allow us to actually capture this without any issues. So let's go from 1,000 milliseconds, which is 1 second. There's 1,000 milliseconds in 1 second. Let's go up to, say, 35 seconds on this. I've taken exposures up to 3 and 4 minutes on this with no problem. But I'm not going to make you sit through that. All right. Okay, so let's do our live stack. Bring that in. We've got 15 seconds. And let's get rid of this. Clear this. That's our last target we just saw. And now, in 1 second here, we'll see our Pinwheel Galaxy. And there it is. What a pretty galaxy that is, too. And look at that, huh? I have to tell you, the first time I saw the objects in this telescope that I haven't seen before, I was just astonished. And you can ask anyone, out here on the East Coast when I ran this telescope here, I saw a supernova remnant called the Veil for the first time in my life in the telescope. I was astonished at how beautiful it looked. Astonished. Okay, let's color correct. Our curves are pretty good though. And then I would like to do another process to darken our sky and give us our contrast. Look at that. Now we'll zoom in on this a little bit. This looks like as I said, a pinwheel. This is a galaxy that has spiral arms, probably due to something we call a density wave. Now, what's a density wave? Well, we know that the spiral arms appear to rotate, right, in the galaxy. But it looks like they're winding up, doesn't it? It doesn't look like a child's pinwheel toy. It looks like the spiral arms are winding up and getting tighter at the middle, and then, like, for instance, this arm starts here and goes wrapping all the way around. What's making it wrap? Well, what's making it wrap is something called differential rotation. The inside moves a little bit faster than the outside. All right. Now, how that works is related to how close you are to the center of gravity of an object, right? when you actually move closer to the sun, you have to orbit the sun faster to stay in orbit. When you're farther away, you can orbit at a much more leisurely pace. So we expected to see differential rotation in galaxies, but what we didn't expect was to see that the differential rotation curve wasn't what we expected. It actually turned out to be not quite, but almost flat, meaning that the rotation changed a little bit as it went out. It got a little bit slower out, farther out, but not nearly enough. Not nearly enough. The galaxy was effectively rotating like a record, where the outside was rotating at an angular velocity that kept up with the inner, faster rotating things. So how could that be? Well, they couldn't figure that out for decades, actually, until they chanced across the concept that was championed by Fritz Zwicky, and that is dark matter. Dark matter that was actually hypothesized by Zwicky is a material that kind of encompasses everything in the galaxy and helps it kind of rotate more or less as a solid disk. Now, when I say solid disk, and that kind of ruins the notion that it's differential rotation. What's differential? The inside spinning faster than the outside. Okay, and so we see that happening. You know, like Jupiter's moons go around Jupiter fast. Okay, the Galilean moons, but on the outside, moons that are farther out, they go slower. Io goes around Jupiter fast, and Callisto, the farthest one out of the Galilean four moons, goes a little bit slower than Io. You know, so this is what we see. We see stars near the center orbit the galaxy a little faster than the stars outside, but the ones outside should be orbiting a lot slower, and they're not. And for 13.8 billion years, or say 13.5 billion years, this galaxy's been here, and its arms are not wound up. And the reason they're not wound up is because the galaxy has it's spinning almost like a solid disk, right? But not quite. So the arms do trail back a little bit, and at some point there is a disturbance in the galaxy, and it's a resonance that causes the spiral arms to actually form. And when we look at it up close and we try to figure out, besides the satellite that just went through, okay, you look here and you see this stuff right here. Let me just show you. Okay, this stuff right here, this is the blue hot young stars that are forming in the spiral arms. There's a line of them right here. Okay, there's a line of them right here. That's actually rather pronounced. Okay, and so that this is a line of hot young stars that have formed in there, and that's what happens in spiral galaxies, is that the arms are where it's at for star formation. There's always stars forming in the spiral arms, and that's why we think of the spiral arms as where the stellar formation takes place, and that happens here in M101, the Pinwheel.
If you look at the spiral arm on the left, up at about 10 o'clock there's a sharp crook in the arm.
This one?
Yes, and then it's spread farther out than the other spiral arms.
Yeah,
it looks like another case
out.
of... Excuse me?
I said let's bring that out. I'm going to
It looks like another case of, gravitational interaction distorted that spiral arm.
Yeah.
And the one obvious candidate is there's that little fuzzy over right there. Might be a satellite galaxy, but would that have enough poop to do that? It has obviously interacted with something in a major fashion
Yeah,
to
because
to
it doesn't even look like a galaxy anymore.
to contort that arm that way.
Yeah. Hey, Hunter. Yeah, no, you're right. And so, like, if we drop this down, okay, that looks pretty. And it looks like we have what looks like a supernova remnant out here.
Uh-huh.
And what's interesting about that is this arm, like Daryl said, is pulled out like this, right? But then there's more stuff out here. It looks like there's more stellar material out here for this galaxy. Let's go see if that's really there.
If you look at the spiral arm at 12 o'clock, it also is distorted.
Well, we got this distortion too.
Yes. Closer in, it's got a crook in it also. It just, if you were to consider a nice, pretty, regular spiral galaxy, it will be even on either side.
Yeah.
That is, it's like bilaterally symmetric. What one side is doing, the other side should be doing.
Yeah.
And in cases like this, and we see this a lot actually, is the galaxies are often distorted, one side relative to the other, and that's where it has gravitationally interacted with another galaxy.
Yeah.
Sort of like we saw with M51 earlier.
Yep.
About halfway out on that left-hand spiral arm, over at about 9 o'clock or so, there's a very bright blue area there.
This right here?
Yes.
Yeah, that, when we talked about spiral arms, guys, remember I mentioned, as Daryl has, I think, in the past too, that the spiral arms are the star formation regions. That's why they tend to be blue, because the stars that form are hot and young. So, when we talk about, little areas like this, for instance, right here, that Daryl's talking about, that could be a hot, young star formation location. We also see areas like this right here. This is another one. Okay, what's in here? What's going on in there? It's a string of stars that have formed in there. Then we have this very hot region here. Okay, and that kind of got goofed up on me. So we actually see a really interesting region there. Like I said, that's very hot young blue stars. Right in here, more. All right, up here, more. So the galaxy spiral arms, and this all over here. So the galaxy spiral arms are areas where stars form, and you can't escape the fact that they form in these regions. And this is where it's at. This is where the whole new star formation occurs, right? Right here, we got more. If you notice, the galaxy is full of these areas. I might as well just stop doing it. So this is Measure 101, the Pinwheel. I'm gonna label it as such. We're only at 17 exposures here. That's all right.
That's another very nice galaxy.
Yeah, it's coming out well. I remember last time there was a point we took this image, and it wasn't actually, it wasn't very good. And I don't remember what it was. This is a galaxy. Well, let's try and color correct, 'cause there's a little green in here. Let's get rid of the green. Alright, so now you see beautiful colors of this galaxy. And they will actually, these images will look better shortly. Let's pull out a little bit here.
There's a big hole in it over at about 4 o'clock.
Over here?
With another 4 o'clock.
Oh, over here.
That right there. And there's another big bright area just below that.
Right there, yeah. Yeah, this galaxy has definitely taken lumps from some other galaxy somewhere, and someone out there is probably thinking, "Well, zoom out. Let's see what else there is." And we have this guy right here. All right, and if we zoom out, I think that's the only one of note. There's one down here, just out of frame. So it could be that one too. There's a little one up there, but I'm guessing that's probably farther away. Yeah, sorry we had to start at 10:45 tonight. It's getting dark later out there as summer approaches, and we'll probably be starting at 11 o'clock by the time summer rolls around. So, sorry about that. 11 o'clock Eastern time. All my times are Eastern time because I'm in Connecticut, telescope's in Arizona.
It's only 9:07 in Arizona.
That's correct. Exactly so. Exactly so, number one. All right, there's 22 images. I don't mind that little red line, so I'm going to save it.
Is that a satellite? If
Yeah.
so, why is it red?
I'm not sure. There's a number of reasons why it could be red.
Well, I guess maybe if it was...
Sunsetted.
Yeah.
When it crosses the terminator, satellites will tend to be yellowish red right in the last few seconds. And we're kind of zoomed in a little bit, so the trail could have been turning red from a satellite that was seeing sunset from its perspective.
Right.
And so it looks that way when we see stuff out here. All right, this is cool. All right, so now this is 23 shots. Okay, 24. Okay. All right. All right, let's see if I can do a little better on the coloring. That's nice. M101, the Pinwheel Galaxy. Alright, folks. Time to move on to the next item in the show.
Want to stick in Ursa Major for the moment?
Maybe. I have another thought process here. I was thinking about the Owl and the Surfboard Galaxy. Which, not this one. Where is the Owl? The Owl's a planetary nebula. And,
97.
yeah, I'm trying to remember where it is in the... Is that Ursa?
It's down along
down?
the bottom of the bowl, closer to
It's kind of where I am.
Marc.
Oh, wait, no, that's not where I am. That's up here.
And M108's right next to it.
Yeah, exactly. And that's the Surfboard Galaxy by any other name.
Yeah.
Alright, well, you know what? I have an easy way to find it. I want you to see this amazing planetary nebula. Because it's beautiful green, it's stunning, and it will just knock your socks off. Look how close I was. Alright. All right, so we're going here, and what you're going to notice, all right, notice the words are upside down. So we're going to go look at the Owl Nebula right here, but then you're going to see a galaxy up here. This is Messier 108, the Surfboard Galaxy. Okay, and we'll be looking at that. There's a rumor there's a supernova that went off in that one, and I want to try and image it anyway, just to see if we can find it. All right, so let's go to the surfboard and the owl. Telescope is leaning way back over its head. Here we go. There it is. There's the owl. And the surfboard galaxy is going to be up here. So I'm going to drop us down a little bit. What's interesting is these objects are in the same field, and I think it's pretty cool. All right, I'm going to start us up again here.
Isn't 108, I mean, you call it the surfboard, isn't that the same thing as the whale?
No, the whale's a different galaxy on the other side of the sky.
Okay.
All right, let's head west a little bit. Surfboard is like right over there. There it is. It's coming in. So you'll see two objects here for the price of one. And this one's a planetary nebula. It's from a star that has died. And you'll see the white dwarf in the center just a minute. But first of all, go away. And then you'll see in the surfboard, you'll see a very interesting modeling and spiral arm structure. There's sort of an edge, a galaxy that's kind of like this to us. So you see it kind of at that angle. All right, so we'll try this for now and wait for our system to get a guide star. In fact, I want to move these up like that. And move this up. Okay. All right, as soon as we start guiding, we will take a nice image. And we've calibrated to zeros, and now we're ready to go. Okay. I'll wait for us to stabilize. And looks like we're stabilized. Let's do a 35-second shot of this region right now. All right, 35 seconds underway on the Owl Nebula right here, a planetary nebula way up here in our galaxy, and the Surfboard Galaxy way up here, which is way out here, millions of light years away. All right, let's bring up the stack. Let's get rid of this. Remember, that's beautiful. Okay, we got about 5 seconds. So we'll clear the buffer in preparation, and then bam, here comes the owl and the surfer. Look at that. Now, where's the owl? It's down here. Look at that. Let's do this and then color balance.
Oh, it's green.
Oh, it's very green. Yeah, 35 seconds is almost too much. I have to drop down this value here so you can actually see the white dwarf inside. So here's what we're going to do. Okay, the white dwarf is the remnant left behind. When a star uses up its hydrogen, its core begins to contract. And when it contracts, it sends out a huge stellar wind, and that makes the star bloat into a red giant. Okay, so what happens over time is it goes through several more cycles of fusing materials like helium and stuff like that, carbon makes carbon, okay, and so out of the helium ash, and so when it makes carbon, it'll tend to start contracting more, and eventually some oxygen is made as well, and it'll contract and contract and contract until finally you've got nothing but carbon and oxygen left behind, okay? And the stellar core is no longer fusing. It actually kind of separates the outer layers by this copious stellar wind pushing out, and so it actually makes an envelope around the star of the star's former innards, and that's what we're looking at right here, is the remaining innards of a previous star, okay? And let's let me see if I can remove some enhancement here, see if that helps. Okay, so there's the white dwarf. Now that's a stellar core, a stellar remnant. Notice how blue it is. It's very, very hot. And hot things are very blue. This is an artifact of the camera here, by the way. So is this one, this blue things. And those don't matter, neither does this red one. And those are random dead pixels. They actually are not always dead. It's a per photo deadness, if you will. But look at that. So you can see this green. That's ionized oxygen that this star has blossomed off of itself in its final death throes. It's ringed by potentially some hydrogen out here, which you see is red, or neon that glows red as well. So it's all because of the ionization. Now let's put the mask back on. Go back to the histogram here, and let's do this. Let's pull down the values so you can see a little bit more about what's going on inside. So you see this strange, it's really strange in here, and that white dwarf, again, very blue, very hot and blue. That's how things are. And then when they're cool and red, like this one star over here, okay, then they're much lower temperature. The temperature is cooler, and it's not. It tends to go to red. A lot of detail in here, but let's let it set where it wants to be, and let's go back out and look at our surfboard galaxy and then play with it.
After we look at M108, I have a good candidate for the next one.
Nice, thank you. That's a good idea.
We could spend all night here in Ursa Major.
Oh, I know we can. Okay, so this is the surfboard galaxy, and I'm going to capture this image and save it exactly as seen for purposes of hunting for the supernova that is rumored to be in this. All right, we got 8 frames. I'm going to save it. The whole frame is saved, not just this. And if I save exactly as seen, I'll still have to zoom into the final image to see this, because I'll show you what you actually get. If I click on this image, it brings it up. Right, that's the image that's saved. Okay, so it's saving everything. All right. Yeah, I think Kyle, who says he thinks he found the supernova in this, he sent me the photo right away, and I looked at it, and I'm not sure. I think this star is the one that's there, and maybe this is the one that he was talking about. I'm not sure. I'll have to ask him.
I'm looking at a reference image. Which star?
Look for this star right here. See that guy?
Yes.
Yeah. Look for that star.
I think I see that in the reference frame.
Yeah, okay. I told him he had to be careful about calling things transients like that, because he really needs to study images beforehand to see what he's really looking at. It might be, this looks like a H2 region, a stellar nursery in there. And I think this star is in there, but you can tell me that as well. So you got 1, 2, 3. And there might be something there, but that looks like another stellar nursery. Look at all the red though in there. That's a galaxy that is undergoing a lot of star formation. That's a lot of ionized hydrogen. Very nice. All right, let's go down here and see.
They call this a barred spiral.
All right.
I'm having a hard time seeing the bar or the spiral.
Oh, well, I think I have a way to show you the spiral. Here we are at the Owl Nebula again. It's called the Owl because it looks like these are two eyes with a round-faced owl. And he's got a white dwarf, a star about the size of the Earth, the stellar core about the size of the Earth, just blasting, very, very hot, 30,000 Kelvin temperatures and ultraviolet energy out into the gas that it's expelled off itself, thus ionizing it. And these white dwarfs are pretty well understood. There's several different kinds. There's a carbon and oxygen dwarf, of course, and that's probably what this is. And then there's another dwarf that's predominantly other elements in addition. And this particular white dwarf, I think, is a carbon-oxygen surface dwarf. And this material in here is just the oxygen layer that the star was made with. It blew off. Because it's a star kind of like the sun that does this kind of thing, that makes this kind of a nebula. And we call this a planetary nebula. Probably because it looks like a planet in a small telescope.
Article for M108 says that there was a supernova on March 13th, 2023.
Okay, so that's what he was looking at.
Supernova 2023 DBC, type 1C supernova, likely a stripped envelope supernova, as there is no evidence for hydrogen in the spectra beyond narrow emission associated with the underlying H2 region.
He's not talking about this. He's talking about this up here, guys.
They don't point it out.
Yeah, it was over here somewhere. Let's see if I can see it a little brighter. It was over in this region right here. I do not see it now.
Yeah.
All right, well, cool. So we'll save it. And save it exactly as seen. And I'll use it to do a comparison. Oh, why didn't guys tell me to get off of here? Huh? I had the wrong title there. Sorry. Okay. Put that out there. Oh. Owl and Surfboard Galaxy. That's what we're looking at now. And we'll zoom out to see them both. And there we go. Okay, now you had a candidate you wanted to look at?
M109.
Alrighty, where's M109?
It's just to the left of this field.
Alright.
Dubé, Marc, Fecta. It's over by Fecta.
Kind of like a trifecta?
Affecta at any rate.
Alright. Okay, so it's not that one. Measure 109.
This is a nice sparred spiral.
Oh, the vacuum cleaner. Okay.
Looks like a steering wheel.
Yeah, this is the vacuum cleaner. We saw this. Alright, here we go. It's Galaxy season. Alright, so let's do that. Let's go find the vacuum cleaner in Galaxy, which is kind of a funny name. Night vision mode here in SkyTour Livestream, and now we're going to the vacuum cleaner Galaxy. You know, I know people are thinking, should I see a vacuum cleaner? And why is it called a vacuum cleaner Galaxy? I don't know. Maybe because somebody thought it looked like a galaxy that looked like a vacuum cleaner. Or
there was an image up at Space Weather a day or two ago.
Yeah.
Of a guy. I think he was in Alaska taking pictures of the aurora, and this big blue spiral came up above the horizon and went right overhead. Did you see that?
Oh, was that the rocket launch?
Yeah, it was a SpaceX launch. The second stage was venting gas, and it was making a spin.
Yeah.
And it looked really incredible.
Actually, that's one of the stories that I had to do for this last season of The Proof Is Out There on History Channel. I just did it a couple weeks ago. Not even, about a week ago. So, you'll see it. I won't. I don't have cable, so I never get to see it. Alright. But I saw that. It was really pretty.
They even got video of it.
Yeah, it's cool. Okay, we're going to clear this now. After our last look here. This is the buffer for our camera. Currently the sensor is building up an image, and if I don't take this one off, then the other one won't come out. So it won't come off, so I'm going to clear this, and we should now get our next image. There we go. And there is the vacuum cleaner Galaxy. Oh, that's neat looking. I can't remember this. Let's color correct. Yeah. The blue halo is an artifact of the system we use. It's fast, but you do end up with the halos, which are kind of reflections from the primary mirror of the telescope. And these wires here, I'm gonna remove those. I have a semicircular wire guide that I'm going to install, and it'll get rid of the wires almost entirely. Look at that. Have you seen the wire guides, Daryl?
With Hyperstar?
Yeah, they're wire guides that are actually... I had to clear it because I didn't wait long enough for the guiding to stabilize. I was too anxious. Yeah, for when you have a Hyperstar, the wire guide, you know, to help route the cables so that you don't see the cables in the view.
Yes.
Yeah. it minimizes them if you make them go on a curve.
Yes.
So I'm going to 3D print a wire guide. Alright, so we're going to check this out.
What that'll actually do is should knock down the diffraction spikes around the star itself.
Yeah. It also knocks down the wires visible.
I should bet you money on that.
No, I watched it. I saw it being done.
Hmm.
Well, this is the galaxy he was telling you about, guys, and he's right. It is a barred spiral, and you can see by barred we mean that the nucleus is elongated, and then off the nucleus that's elongated we have the spiral arms coming off there. See that? Spiral arms come out that way, then off of here, off of there. I mean, this is pretty. It looks really nice.
Smaller than I was expecting.
That's okay. If we actually do some of this, we may be able to. Let me also remove the enhancement. Might reduce some of the noise a little bit. So you can see this is part of the bar. Spiral arm goes this way, and this one has a spiral arm that goes this way. Interesting. Marianne is here.
Hello, Marianne.
Hello, Marianne, and also hello to John Dover and Stan Milford, who are visiting with her right now. And as usual, there's this thing over here. That must be another dim galaxy. I've seen that last time we looked at this. I'm not sure what it is.
Well, it looks like a galaxy.
Yeah, it's probably a fainter galaxy. Yep.
There's another one at about 6 o'clock to
Right
M109.
there. Oh, yeah. Alright, and this is now M109, a galaxy. C&D boy, you're funny. Saying there's no need for the taser. Hilarious.
Galaxy appears to be spinning counterclockwise from our point of view.
Counterclockwise?
Yeah. The arms are trailing clockwise.
It looks like it's spinning this way.
No, it doesn't. If the arms are trailing, they're pointing clockwise.
Yeah, so it looks like it's spinning clockwise because this is the nucleus, right? And
Yeah,
this is an arm coming out.
The bars and
Is that not how you see it?
no.
I look at it like the arms are trailing that way. Well, let's zoom in more.
If you look at the arm that's at 12 o'clock
Okay.
and follow it.
Yeah, it looks like it goes this way. But then again,
Well,
it
the
can't.
next arm out. The next arm out.
Yeah. Well, we have to just let the picture clear up before we can do that, but you could be right. So you see this arm is going this way. And this arm is going that way. It might be. It might be, and that would make it go counterclockwise. Interesting. Let's see what else is in there. Let's just do a big push on this. Interesting. Looks good. And this is measured 109.
And I have another one for you.
Nice. That's like.
Bonnie asked for it.
Did she?
Yep.
M81 and M82?
No.
Oh, good.
If you'd like and want to do those first while we're still in Ursa Major, sure.
Okay, now let me save this one. That's pretty good. We have 13 frames saved here. 13 is a lucky number for us. Alright, save exactly as seen. So that's up there now as M109. And now let's look at our night vision mode and go to the next one. Do you want to do Bode's Galaxies now?
Well, sure, while you're still in Ursa Major.
Okay.
And then she wanted to see Messier 100, which is down in Coma, which is also another face-on Grand Design spiral.
Yeah. Would we be able to see that yet? I wonder if we can see it yet.
I bet you can.
Okay.
I don't know. See what Stellarium says.
Okay. I don't need to go to M81 yet. M82, I can try that. Let's go see where it lies. Measure 100.
Well, if it is too early,
I mean, that's right in the middle of Coma Berenices right there. Let's find out. I don't know. I don't know. I think we can see it. And then we can... Let's see if we can do this. Let's go now and see if we got it. I remember the Blowdryer Galaxy. Again, the Blowdryer Galaxy?
the vacuum cleaner galaxy.
I know. There it is, right there, and we're not going to have any trouble looking at any of the galaxies in Coma Berenices now.
Yeah.
Awesome. Okay, Michael Hedrick has a good question. I'm going to answer that question. We're just starting up now, guiding, and we're stable. So I'm going to take us to a 40-second shot here. So, Michael asked a question. He says, wants to ask about one of his wild space questions. Okay. And it is, what are the consequences of doubling the speed of light? Well, that would be a problem for us, because if we double the speed of light, it means that a lot of things that depend on the speed of light will change. Like a very simple one, the mass energy equivalence formula, E equals mc squared. Double the speed of light, and it means that you get a lot more energy. I didn't wait long enough. I have to clear this. You get a lot more energy for a smaller mass by quite a lot, because it goes by the square of the speed of light. So if you have a result that comes out energy of 2 for whatever mass and c squared you have, you double it, it comes out to 4, so you get twice as, a lot more energy. It's actually not actually a factor of 2, it's actually a factor of a square for the speed of light. So the energy goes up by a substantial amount. It's still not right. Where's my guider? We might have wind, but I don't think so. Let me, that's a really pretty
Michael,
galaxy.
I don't know if it'd make it easier or worse for you if you were to consider it's not just the speed of light, it's the speed of causality.
It probably makes it worse.
I'm sorry.
That probably makes it worse for him.
Probably.
That's my guess. And yes, the black holes slow light. Okay, now we're going. No, they don't. Light is unaffected by black holes. How's that one for you? You're going to say, wait a minute. But light is black holes suck in light, and it can't even escape. No, they don't. And then you're like, wait a minute, what's that mean? Black holes don't suck in the light, okay? They don't. Yes, they have a gravitational pull so strong that not even light can escape it. But what it's not escaping is the curvature of space-time that is so deep caused by the black hole. Light is a car traveling on a road, all right? Think of it that way. And however the hills go, the light follows the hills, right? I mean, the car, right, has to follow the hills. So that's kind of weird looking. So as light follows the curve of space, so too does a car follow the curve of a hill. And so the car is constrained to the hill. It can't go through the hill. It can't go into the air. It has to follow it. That's the same thing that happens with light. Light follows follows the curve of space-time, and black holes are really good at bending space-time. And so when you have a black hole, there's a certain point of no return on that black hole called the event horizon. And that's a point of no return because as the light travels over the event horizon and into the black hole, it's so deeply curved that the light, when it goes in, it can't get back out. It's not because it's being held by gravity. It's not. It's following the hills. And this time the hills are in an endless circle inside the black hole just past the event horizon. So that is why in this particular case with the black hole, light can't escape it. It's a two-pronged problem. It's not that the gravitational force pulls light in. It doesn't. The gravitational force bends space and the light follows space. And if you bend it deep enough, light can't get back out of the hole.
And beyond that, light cannot be slowed down by its nature. The speed of light is the speed of light. Speed of causality, whatever.
Well, within a vacuum.
What it can do is it can redshift the light. It won't slow the light down, but it can, redshift it.
Well, there's the issue with black holes is as the light passes through. Okay, let's say it this way. Let's say your spaceship is unfortunate enough to go through the black hole. As it gets to the event horizon, you'll actually end up seeing an image of your spacecraft forever on the face of that black hole where it entered the event horizon. And that is the result of the light not quite caught and not quite free. It's that balance point. And so black holes will tend to accumulate, I would think, lots of objects on their quote-unquote surfaces. But that's really not the surface. That's just the border of the black hole, the edge, the spherical. It's not even a surface. It's just a transition zone to something else. Gladys says, so if a person ever went into a black hole, would the person be following the bend? Good point. Yes, they would. Or would they just die? Both. They'd follow the bend until they'll die. And here's the reason. If you think about it, as you get closer to the black hole, the gravitational force gets exponentially stronger. So if you're falling feet first into a black hole, your feet will eventually feel far more of a pull than the rest of your body. And Daryl said the term before, I've said the term before, you become what's called spaghettified. You theoretically become an infinitely long string of atoms. So you'll get pulled apart and be a long string of atoms making your way into the black hole. Not a very nice way to go.
Well, that's a gradient.
I'd go head first.
That's the tidal effect.
Yes.
Can we zoom in on Galaxy?
Yeah, just a sec. I'm just reading the questions here. All right. And Daryl, you got to be careful about the speed of light. The speed of light does have different values for being in water, being in air, being in a vacuum. The speed of light in a vacuum, you have to explicitly specify.
Yes, I know that.
Okay. Well, we said it doesn't change, but in space it doesn't.
I mean, by definition.
Yeah, in space
186,282 whatever miles per second. That's in a vacuum.
Right. And that's not even the exact value. I mean,
well, you know what I mean.
No, I know that, of course.
And for what Cosmic Ray says, yes, if it's not in a vacuum, light can go at different speeds. Light slows down in water, slows down in glass.
Yeah.
Slows down in different elements.
Yeah.
Excuse me.
Hey there, John Proctor. Okay, John Proctor says something neat. And hi there, Alicia Clark. Speed of light is constant in space. Yes, in space it'll be constant. Traveling through space, absolutely. John Proctor says, I'm going to publish my ignorance here. Nonsense, John. There's no dumb questions, right? But there were expeditions whose purpose was to observe stars near the boundary of the sun in a total eclipse to measure the bend of space near the sun. Absolutely correct. In fact, that was a proof of Einstein's equations, actually, regarding gravity, because he said that space would be bent by the gravitational strength of the sun. And so by looking at the stars, indeed they are. And we've come to know it when we look at galaxies and clusters of galaxies. We've come to know this as a galactic lens. Okay, so basically it's a relativistic effect that occurs when you have a very, very high gravitational object in the foreground and something in the background that's like a galaxy cluster. As the galaxy cluster's light passes this high gravitational object in the foreground, the galaxies will form a ring around the gravitational center, and they'll be warped, and that's called a gravitational lens. It can be microlensing, which is how some planets have been discovered. It's really cool.
Now we can see Messier 100.
Yes, we can. Let me see if I can...
Grand design spiral.
It's a gorgeous spiral.
I see a bunch of other galaxies in there.
Oh yeah, there's quite a few. Actually, and that's only there. That's if you want to see them. There's more out here. Look at this.
Oh yeah.
We're in the Coma cluster, man.
Mm-hmm.
And we've got one here. We got them here. We got one there. And then that little guy. This is the full size. Remember, 4 full moons across, 3 full moons tall. Yeah. I always find it fascinating because you look at things like this and you say, well, who's going to pay attention to that little galaxy out there? Okay. And there's probably some beings on a planet somewhere in that galaxy looking out at ours saying, I wonder who's out there, if anybody's out there. Because the interesting thing is, every life form on our planet exhibits a factor that is interesting because it speaks to our desire to know if we're alone or not. But every life form is like that. Every life form on the planet, it has curiosity. Curiosity about, is that something I can sniff and eat? And what is that over here? I hear a noise. Let me go investigate it. Dogs do that all the time. Cats do that. Hear a noise, you go look and what is it? Okay. So it's a curious nature. That curiosity is imbued in all carbon-based life forms. So if there's other carbon-based life forms out there, and I think that that's probably the primary ones that we'll see, because carbon is the 4th most abundant element on the universe. Okay, oxygen is the 3rd most abundant. It's even more abundant than carbon. And then you have helium and then hydrogen. Well, if there's other carbon-based life forms, like in this galaxy right here, then they're probably reached some level of intelligence too. This galaxy doesn't look like it's been through too much torture. And we have a pair of satellite galaxies around ours galaxy as well, along with the dwarf galaxy that's circling us a little farther out. So we have, we have our share. And I think there's probably carbon-based beings out there that use oxygen, and we'll be looking for planets with oxygen in the atmosphere. So, that is, I think, a tenet of the universe, is that carbon-based life is what this universe is all about. I'm a carbon bigot, yes. I'm prejudiced, big time. I'm pro-carbon.
Can you zoom in again?
Okay.
If you look at the spiral arm that's passing from
This one?
the inside one, from 3 o'clock down through 6 o'clock, there's a bright line in that galaxy, curved line,
This
that
one?
runs to about 7:30 o'clock and just stops. And then the arm keeps going up all the way to 12 o'clock. But that one bright line part, which I guess is where the active star formation is, ends right there at about 7 or 8 o'clock.
You talking about this?
Yes.
Looks like it continues around all the way to there.
But if that brighter line part stops at about 7:30 or 8 o'clock.
I mean, this part of it right here.
Yes.
Yeah, I guess that's true. Also looks like it kind of trails off out here somewhere, but we'd have to capture more images to be sure and then process them. Let's try to punch it up. See, now we can see that this bright line, like you said, it comes to about here. Then it becomes kind of softer and not as mottled all the way out to there. Yeah, so
Well,
that
it looks to me like it cuts off.
No, that's what I'm saying. I'm saying it's bright and extensive here, but then it seems to trail off out here, right? But it's that this blue thing is kind of like the demarcation line,
Yeah.
ending what's going on here. Now let's actually pull this in.
Alessia, clockwise, no. It's all just a matter of orientation. I mean, you know, if we were on the other side of that galaxy, well, it would look like it's going the other way, spinning the other direction.
Yeah, if it was this side versus this side, there is no up or down in space. That's what he's trying to say, Alessia. So because there's no up or down, it just depends on what side of the galaxy we happen to be looking at it from. If we're looking at it here, it's going this way. It's going clockwise. But look down here, looking at it, the same rotation is going counterclockwise to our eyes.
And again, if you split that galaxy in two, an ideal galaxy would look the same on either side of that line, going right through the center. But you can see that it's not. It's a little lopsided. And there's a big feature at about 9 o'clock to the left of the nucleus. It's a lot fatter on the left side of the nucleus than the equivalent side would be over on the right side.
But if we split it this way, then we can make the argument that it seems similar above and below this line, kind of. I mean, this arm here could be this arm here.
But they're not.
Correct. This one's closer.
The upper arm,
farther.
Upper arm goes much farther around. The upper arm is going about 2/3 or 3/4 of the way around, above your red line there, and the one on the lower right side is only going about a quarter of the way around, halfway around.
Well, it ends here.
Yes.
And this one doesn't end there. It continues to about wherever here. It's kind of hard to see.
But there are, looks like plenty of other galaxies nearby that it could have interacted with.
That's for sure.
And the one on the left side at about 9 o'clock, it's got the main arm.
Oh, this arm here?
Right there. There's a big fuzzy patch sticking out toward that galaxy out at 9 o'clock.
Oh, you mean here?
That right there, yeah. See how it's kind of pulled out?
Yeah. It could be. We'd have to see. Okay, we'll save this after this 25th exposure. This is Measure 100. M100. GAL. Okay. Okay. And we'll save it. Save it exactly as seen. Alright. Let's check out something else.
You want to go back to Bode's Galaxy now?
Yeah, maybe. You have another one you want to look at while we're there? I was thinking of both galaxies too, but you know.
Give me a second. See, we did M64 the other night, the black eye. Is that the black eye or the sunflower?
No, that's the black eye.
M100, M99, M98, M91, M88, M85, M64, M53.
Okay.
M53, I want to say is a globular. I forget.
Sounds like a globular. Alright, let's back out of this.
Yes, it's a globular.
We looked at Markarian's chain the other night, and we saw some of these galaxies. And where do we want to look now? That's a faint galaxy. Izabela is asking for the Whale Galaxy.
Okay. Well, we weren't that far off before. The Whale Galaxy is in. Ken has been teaching. So, you know, we're still in that same area of the sky.
Yeah, and it's available. So should we look at it for her?
Sure.
Okay. Here we go. This is for you, Izabela. Cosmic Ray saying, are there any ideal galaxies? Ideal for life, Ray? Ideal for development? That's a good question.
I saw that a minute ago. I think he's referencing what I described as an ideal galaxy, where if you drew a line through the center, it would be
Symmetric.
the same on either side. Symmetric, yes.
Yeah. Our Milky Way could be symmetric. The Andromeda Galaxy is probably symmetric. Messier 33 is not. It's got some interesting little jogs. Probably the Sunflower Galaxy, the Black Eye Galaxy, is not symmetric. Sunflower is. So yeah.
If by ideal you mean perfect, I doubt it. There are some, surely, if we pick through enough images of galaxies, spiral galaxies, that, you know, we could find some that are relatively undisturbed looking. But then again, as Marc alluded to earlier, some say it needs to be disturbed to have spiral arms. But I'm sure we could find galaxies that are close to ideal.
Yep.
And some that are really messed up, you know.
Yeah. No, I'm going to move this over here because we have the Whale here, and then this is the Crowbar Galaxy here.
Mm-hmm.
And we're going to wait for our telescope to grab our guide star, and then we're going to... There we go. I'm going to go guiding here, stabilized.
Remember now the Whale has a little satellite right above it,
Yeah, it
too.
does. And we're going to check that out as well. This one will be a 40-second exposure. Okay, we're guiding good. And there's very little wind tonight. Looks very nice out there. Let's go in here and look at one last time at M100, the Grand Design spiral out there. And that's good. 23 seconds. And the light that hit our eyes looking at this, it's possible that no one else on the planet was looking at Messier 100 right then. Okay. And here comes the Whale and the Crowbar. Boom. Look at that. Very nice.
Uh-huh.
Oh, we're going to let this go. This galaxy looks this way because it has definitely interacted with some other galaxy, possibly even the Whale. Isabella's asking a calculation about What? This is a 40-second exposure.
No comprende.
Yeah, I think maybe she misheard me. Or she's ahead of us and speaking about other things that I should have remembered, but we'll see. Okay, let's color correct this. It's actually pretty well. Alright, and then let's process a little bit here, give us a little latitude. There we go. Now let's zoom in and see what we're looking at. Look at the whale galaxy, look at that. This one here has one end of its galactic disk here is tipped way down. It's actually undergoing some type of gravitational interaction with another galaxy, maybe even this one. Gladys says, "Oh no, I see the giant squid." Because it does look like a squid. Looks like, see, here's the cephalon on the top of the head. Here's the eyes, and then here are the tentacles trailing behind. Yep. So it could be a squid. However, it can also be a giant whale with the head of the whale here, the body, and the tail.
It's another barred spiral. We must be looking at it edge on.
Not quite edge on. It looks like it's sort of like at a slight angle.
Sometimes called the hockey stick.
This guy, yeah.
Galaxies. Actually,
is that also a barred spiral?
what Wikipedia says. Also says it's two NGC objects, 4656 and 4657. Highly warped barred spiral galaxy located Canis Venatici, sometimes informally called the hockey stick galaxies or the Crowbar Galaxy.
Okay. Ray says, I think Izabela wants to know the inner workings of the Mark I exposure algorithms. I know, see, the thing is, in my head, I know the sensitivity. I know the sensitivity of the sensor. I know how it reacts and how it operates. So when I say 45 seconds or 40 seconds, it's not a random thing. It is a calculated thing, but it's based on experience with this particular camera. If I get a different sensor, I'll have to run through enough time with that camera before I go public with it to know how it reacts too. Because there's certain points at which you reach little or no return by increasing the exposure, and stacking has a limitation as well. You can say, well, if you stack 20 it looks pretty clear. What if you stack 1,000? Will it be ultra clear? The answer is no, it won't be ultra clear. In fact, it'll be worse. So it's like, well, when do you stop? You stop when it's done. You stop when you've captured enough. And for me, that's about 20, 25 shots, most things. And sometimes 10, like we just did.
I think I can actually see it now. When you look at the crowbar, it's very faint, but just above the crowbar, there's a faint gassy patch there. Higher
right
up.
there. Oh, this?
Higher up. Right there, yes. That is the second NGC object.
Okay.
And they say it's actually two different galaxies. And that interactions with that and with the whale galaxy is probably what's distorting it so badly.
Yeah.
And they say both the whale and the crowbar or barred spirals.
Okay. Gladys says, "Where's the dolphin?" The Dolphin Head Nebula is down around Canis Major, which is setting now. We don't see it.
Yeah, I think it has set.
Yeah.
There's a constellation, the Dolphin, Delphinus, but
Yeah.
that's up in the
Summer.
summer sky next to Aquila the Eagle,
Mm-hmm. And Lyra.
one of my favorite constellations.
Mm-hmm.
It looks like a little kite.
It does. It doesn't look like a dolphin. Yeah, we're getting some good detail here now.
I think that, yeah, the dim gas cloud to the upper left of the crowbars, I don't know. If I look too hard at it, it goes away, but I can see it.
No, it's pretty clear. Let me see if I can...
Avert vision a little bit, and it pops out a little more.
Let's see if we can avoid averted vision.
There you go.
And now let's actually try this now. Yeah, let me darken that up. All right. Well, I don't know. I think I see some H2 regions down here. Maybe. That's a pretty messed up galaxy. It's been destroyed by a lot of things.
Yeah.
Let's pull this out here. I want to be able to show you the detail inside this guy. Look at that. Now you see how you're seeing it kind of on edge? You can see it sort of like this. You know, like on edge, like, you know. The center of the galaxy is the reddish area. These are the spiral arms. And I can't really see the nucleus, but I can trust that it probably goes through here.
I'd wonder if that white spot, probably a foreground star.
What, this one? Or that one?
The one on the left.
That one. Yeah, I think that's got to be a foreground object if it's a star. When Mark 1 gets a 1201 alarm, I gotta take manual control or we're gonna crash on the moon, Ray. 1201, Roger, 1201. And they just like pushed right through it and landed anyway. We're referring to the moon landings that, yes, did happen. That was a 1201 alarm that almost resulted in, could have resulted in the lunar module crashing on the moon. Isn't that pretty? Really beautiful.
It is.
Let's color correct, see if we can get.
Sometimes they call it the herring instead of the whale.
The Herring Galaxy?
Yep.
So I just did a little color correction, and now you can actually see how there's a more rich redness throughout the galaxy here. There's a lot of activity in here. Probably a lot of star formations, starburst activity going on. Very interesting. Let's pull this a little closer and start to draw more detail out without losing the center. Look at that. It's probably teeming with life. I'm guessing that's
if,
teeming with life.
if we are seeing the barred spiral pretty much edge on, that seems like an even more extreme example of what I was saying
Yeah,
about 4565 the other night, that how different the two halves of the galaxy look edge on.
yeah.
You see the right hand side there,
It's
it's a lot
W.
chunkier, pieces going out, and
This is dragged off.
yeah.
Well, Izabela, this was for you. Hope you enjoyed it. John Proctor says, we'd never be able to see a view like this without you. Thank you for what you're doing. Well, you're welcome, John. This is something that, has been my career for decades. And I finally returning to it in a more full-time manner. So if some of you out there aren't subscribed, why not just subscribe to us? We're free, Just go to skytourlive.org, and you can also see the photos that we take and get right to the database, not the database, the server, and go through all the nightly photos that we've taken for over a year now so far. We've been going for like 3 or 4 years with this, but I only just started doing the server over the last year or two, and we have a lot of data out there. Hundreds and hundreds and hundreds of photographs that you can sift through and enjoy and take down, all for free. Download these types of images and do your own exploration. This data is data that you can use to do your own research. Look for supernovas by comparing the same galaxy images years apart. Now, in order to know when you can actually see, or when we actually look, say, at the whale, you need a database, and we have one. Thanks to Robin Curtis, who has been building our database. We have a really good database, and we're trying to get a front end made so that anyone can search and say, give me all times when the Orion Nebula was shot, or give me all times when this guy here, the whale and the Crowbar, were shot. And then you could go compare the whale from 2 years ago to the whale of today and see if you notice a difference. There might be a difference. There might be a supernova that has gone unnoticed, and you might find it.
You mentioned the Antennae Galaxies earlier.
Yeah, that's going to be our final object tonight, and we're going to go to that right after this exposure.
Okay.
Gladys says, I agree with John. The public really has access to a variety of pictures beyond what, like, NASA posts or something. Oh, that's true, Gladys. And I am very happy to be able to provide these. I find that what we're doing isn't anywhere on YouTube. No one's doing this. It's not on Facebook. No one's doing this. No one is setting up a telescope and taking the time to show you different objects each night and then explain them to you. There's I'm an astronomer. That's what I went to school for. And no one's doing that. I took my astronomy to the public outreach because I think that the more you learn about what's over your head, the more engaged you can be here on the planet. And I just think that that's the very truth, But I love what I do. And you can tell Daryl loves what he does too. Izabela says, what is going on with the database? Well, the database is up to almost... actually, the database was complete until I started streaming a lot more. Now Robin's behind because I made her so. But we have up till, I think, the end of February done of this year, all the way back over a year. So it's got a lot of... it's got all the data except for like the last month or so of observations. And yeah, so that's the way it is. And again, that's why. And Michael Hedrick says the motto is awesome. Yeah, there's two mottos. Number one, the most important thing is science is for everybody. You just need it shown to you in a way that you can understand if you don't have a good background in science. And I'll teach you the science if you don't know it. And then the other motto is that we bring you the universe live in real time. And that's basically what we specialize in. I think that's one of the ones you were talking about, right, Michael? So there we go. So we've got 24 shots. We're going to go to 25, and then we'll stop there. And then going to go to the very small Antennae Galaxies.
The antennae just cross the meridian here, so they're going to be just a little to the east of it.
That's right.
In Arizona.
We're going to be good. All right, so... okay, so this object was for Izabela. So Izabela, you can check out the whale up there. And courtesy of Izabela, you all have access now to a beautiful galaxy. And then down below here, below it, in the same field, we have the Crowbar Galaxy right there. Very strange. And all this subtle stuff is stuff you just won't get to see, really. All right, so that's going up there. I believe I saved it already, but I'm going to do it again. Okay, so now we have 26 exposures. And then I can get rid of this. Go back to our night vision mode. Okay, there we are. And that's what it looks like in night vision mode. And let's zoom out. Alright, now we're zoomed out, and let's go check out the antennae, and you'll see them in Think in My Search because I looked at them the other night. They're down here. There they are. Okay, watch the telescope. It's going to zip around. There it comes. And get down pretty low. Not very low, but somewhat low. And there's the Antennae Galaxies. Very small little objects, but there they are. Or is that them? That might be them. Yeah, I think these are them. That's another galaxy. Okay, so let's head east. Okay, and then head north.
Interesting. Yeah, the antennae are the ones to the upper left.
Yeah, that's why I brought them into the center.
Yeah.
And then we have that guy.
The first one to the lower right you thought was the antennae. That is NGC 4027. That is another pair of interacting galaxies.
Well, then we have to make sure that we see these. Let's go and bring them back and then kind of split the difference here.
Excuse me.
That's okay. You just made everybody yawn. Of course, you weren't the first one. I did it first. Okay. Well, let's check it out, shall we? This will be a 45-second shot. And we'll wait for our guider to stabilize, get in and stabilize. It's going now.
If I remember correctly, these will be kind of small and subtle looking at first, but as the image builds, you'll see the faint detail where they're interacting.
Yes.
They're the antennas, I guess.
Mm-hmm. Okay. 45 seconds and go. Now we're off and running, and we'll go to our stack and we'll review the whale and the crowbar for one last time. These are already up in the server, by the way. Go to skytourlive.org and go down to the next section, and it'll say, take me to really cool pictures. And it'll take you to the directories, and there's instructions how to navigate down to get the pictures. And you'll see FITS files, and you'll see the PNG files. And those PNG files are the ones you want, the ones that we're showing the save exactly as seen ones. Okay, this is the last object anyway. Alright, Gladys, good night. Thank you for coming out here and spending time with us. It was very nice to see you. Make sure you subscribe, okay? Okay, we aligned our curves. Now you can see the antennae right there. And the other interacting galaxies right here. That's pretty cool. Look at that. 2 sets of them right in one shot. And they're kind of small. Yeah, the database out there, Ray, is a it's actually a outdated. It doesn't have all the images in it. So we're not depending on that, but if you want to poke around with it, feel free. Okay. Okay.
Well, Stellarium calls 4027 galaxies plural.
Okay.
Wikipedia calls it galaxy single. It is associated with the antennae though. And
All right.
let's see. Part of the NDC 4038 group. Also contains the Antennae Galaxies.
Okay.
4038 and 4039. 4027 is really cool looking all by itself.
Mm-hmm.
I don't know how well it'll translate here from the wide field view, but
I don't know.
talk about disturbed.
Yeah. Let's see how much we can zoom in on this.
I can see one of the antennae barely showing above and to the left.
Oh, you see that one? Because I'm seeing the one to the right, or down here rather. See that one?
Barely, yeah.
And there's another one right there.
Yes.
Another one right here. You guys see that? Let's see if I take off the unsharp mask if it's more obvious. Maybe it's a little too much unsharp mask. Let's bring this back just a bit. Yeah, you can see one right there.
Yeah.
And one right there.
Izabela says, ha, just had an idea, Marc. You can install ChatGPT clone on the website, you know?
That's true. I could.
Maybe ChatGPT can build even the front end that writes codes. I don't know how to feel about that.
I don't know if I trust ChatGPT.
Right. Well, the whole AI thing, you know, it seems to be flavor of the month or something.
Yeah.
Some people are saying it's going to destroy humanity and every other people. It's going to do everything but walk the dog, and probably even that. I know I'm still on Windows 10, but Microsoft keeps throwing updates at me, and it recently did an Edge update, I guess,
Yeah.
or a Windows 10 Edge update, that I now have Bing AI up at the top right corner of my computer, and I can't make it go away.
Wait, what do you have up there?
Bing AI.
Hmm.
Bing is jumping on the bandwagon. They have an AI now too, and
Why
they
can't you
put it
make it go away? You can't go into your startup programs and tell it not to start?
not that easy. No,
Hmm.
I've looked into it. I haven't managed to get rid of it yet. They want me to get in there in the registry and do command line stuff. But I now have an AI on my computer that I don't want.
Yeah. Well, Cosmic Ray saying good night. Good night, Ray. Thanks for coming. And Louis Ta says, "Ha, I've been playing with AI generated art for some time. Um, yeah, I've seen some of those apps, and I'm as an artist, I mean, I've done paintings and things, and I'm just not a big fan of AI generated art. That's like lazy art. But maybe it's not. I guess if you get to put in, if you can determine what you're going to put into it, then I think that makes it less lazy and more intellectual, which I think is pretty cool and creative. All right, let's see if we can pull this out here.
There's a newspaper columnist I read daily. His name is James Lilacs. He writes for the Minneapolis Tribune, Star Tribune, whatever it's called.
Okay.
He has a website, lilacs.com, and he does a column 5 days a week called The Bleat. And one day a week, it's either Thursdays or Fridays. I think it's Fridays. He has been doing AI generated art. He will come up with some parameters for it, sort of telling a story.
Yeah.
And then he prints the images that it gives him. They're kind of interesting, but
Oh, cool. Let's go
they're kind
see.
of twisted too.
Yeah.
And it's very much a case of garbage in, garbage out.
Yeah. Geico.
Yeah.
Geico rhymes with Geico. Oh no. The gecko is garbage in, garbage out.
So 4027 there,
Yeah.
it does or has interacted with the antennae. And I don't know. Can you zoom in on that much?
I just did. Weren't you watching? I just did. And it's not really. They're so small that it's hard to actually get a really good view. I could drop this down, I guess, and then that'll help mitigate some of the noise. But then we have the antennas. Yeah, it's amazing. We're seeing this snapshot of this, yet in real time, they're moving through each other. And if we could speed it up, it probably goes like this, and moves through each other. Yeah.
Well, cool beans.
Yeah.
Thanks for showing us.
Yeah. Well, we'll save it. This will be the antenna. Galaxies. All right. And we'll save it. Save exactly as seen. And I'm going to bed now. So you guys have a good night. And I'm sure that we will be back with you again very soon, without a doubt. And I hope that you guys end up having a sparkling evening. All right? And of course, you know what that music means. The night is over. The fun is done. Thanks for coming out to SkyTour live stream. Make sure you subscribe if you haven't. Go to skytourlive.org. Drop us a note. Say hi. And we will have things for you to buy very soon. And I'll let you know where that's going to be available. All right, guys. See you all later. And we'll talk to you on the next starry night. Good night.
Good night, everybody.